Hello everyone, welcome to the Mathematics MI channel. In this video, we are going to solve this nice integral from 0 to infinity 1 plus x over 1 plus x to the square root of 5 dx. Well, how to begin? Okay, first I'm going to define an integral from 0 to infinity x to the m minus 1 over 1 plus x to the n. Here dx, as I remember, I solved this integral in a previous video. Okay, anyway, let's solve this integral here in this video. Okay, as a next step, here we can simplify 0 to infinity x to the m minus 1 over 1 plus x to the here m raised to the n over m power dx. Now we know this m and this m get cancelled, and so we have also x to the n. Okay, let us take the substitution. So let's take u is equal to x to the m. Then if we differentiate, we have du is equal to m times x to the m minus 1 dx. Well, now let's plug in. So we have limit, we know also 0 to infinity. Now x to the m minus 1 dx in the numerator, we have x to the m minus 1 dx. We have 1 over m du. 1 over m is a constant, so 1 over m du over here 1 plus x to the m, we know u, so u to the n over m. Well, then to solve this integral, again we can take a substitution. So I am going to take u to the n over m is equal to tan square of theta. Then if you isolate the u, we know u is equal to tan to the 2m over n of theta. Now let's differentiate. Du is equal to here 2m over n tan raised to the 2m over n minus 1 of theta. According to chain rule, here derivative of tan of theta, we know secant square of theta d theta. Okay, let us plug in here. Now here we have 1 over m integral from 0 to lower limit when u approaches to 0, we know theta also approaches 0. Upper limit when u approaches to infinity, theta approaches to pi over 2. Then du, we have this part 2m over n as a constant, so we can write here outside of the integral sign 2m over n. Now here tan raised to the 2m over n minus 1 of theta secant square of theta d theta over 1 plus u raised to the n over m, we know tan square of theta. Then we know tan square of theta is equal to secant square of theta. So we have the same also get cancelled. So we have 2 over n integral from 0 to pi over 2. Now tan to the 2m over n minus 1, we can write by using sine and cosine. So we have sine to the 2m over n minus 1 of theta times cosine to the 1 minus 2m over n of theta d theta. Okay, now this is very famous format, because we know this is about just beta function. So we know beta of ab is equal to 2 times integral from 0 to pi over 2 sine raised to the 2a minus 1 of x times cosine to the 2b minus 1 of x dx. So we can convert this integral into a beta function. So this is equal to here we have 2, so 1 over n beta of here m over n comma 1 minus m over n. Now we know the relation between beta function and gamma function, so we can convert beta function into gamma function. So we have gamma of m over n times gamma of 1 minus m over n gamma of m over n plus 1 minus m over n get cancelled, so we have gamma of 1, and gamma of 1 we know 1. So also here we have gamma of m over n, gamma of 1 minus m over n. So let's call the Euler's reflection formula. Gamma of x, gamma of 1 minus x is equal to pi over sine of pi x. So we know this is equal to 1 over n pi over sine of pi x, we know now m over n. So our integral from 0 to infinity x to the m minus 1 over 1 plus x to the n dx is equal to pi over n times sine of pi m over n, sine of pi m over n. Well, now let's solve our integral from 0 to infinity 1 plus x over 1 plus x to the square root of 5 dx. Now we can split this integral into two integrals. So 0 to infinity 1 over 1 plus x raised to the square root of 5 dx plus integral from 0 to infinity here x over 1 plus x to the square root of 5 dx. Okay, now comparing with this integral, we know here for this integral m is equal 1 and n is equal square root of 5. Then for this integral we know m is equal now 2 minus 1, so 1 power x, so here 2, and n is equal to square root of 5. We know here pi over n is a common factor, so pi over now n we know square root of 5 times 1 over sine of 5 m over n, so 1 over sine of m we know 1, n square root of 5, so we have sine of pi over square root of 5 plus here again 1 over sine of now m2, so 2 times pi over square root of 5. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.